Welcome to COM 2026 OOP. Today we're going to talk about variables in Java. Data is digitalized and stored in a computer using some predefined format. Whether it is a number, some text, images, or videos, they are all stored in a computer in a binary format, namely 010101. Okay? Now, how these digital contents is stored? In the computer, all these 0101 binary digits is stored by the logic. We group 8 bits into 1 byte. For historical reason, byte a byte is a minimum unit we use to describe a data. Now, some data may require more bytes than the others because it need more memory to store it. For instance, if you have a paragraph that has a lot of text, images, or video that consume a lot of bytes. Some data which use less um, memories, such as the small integers or the logic true or false, that will require less um, bytes or bits. Now, we know that when we store data in a computer, some consecutive memory address will be consumed, just like what this diagram is illustrating. When we store some text, when there is only one character, we call this a char character. When we have more than one characters, then we will say it is a string. Each character is uniquely represented by a system called a unicode. A unicode consumes 2 bytes of memory to store it. Okay? So, for instance, this A, we use 2 bytes. The first byte will be 00. The second byte will be 40 plus 1. So 0041 to represent this capital A. And so on for this one will be 0042, 0043, and up to this J will be 004A. Now, what does this 0041 or 004A actually means? These numbers, what we call hexadecimal numbers, is the numbers that we going to use to represent this character capital J. A hexadecimal numbers is also named as base 16 numbers, which is a little bit not conventional in our daily life, but it is very, very common when we referring memories or internal representations in computer science. Now, so look at this example. Let's say we have a string com2026. C, small c, that will be here, which takes the value 0063. Okay? And O, this one will be 006F, that will be all. So if we're going to decode this one into pure Unicode system, we got the value 0x63, 0x6F. Now this hexadecimal numbers is a base 16 numbers. Of course, we can represent them in a decimal number as well. When we're going to store a number as a number, which is not COM2026 anymore, but just a number. That will be much more easier, and we can store it in a more efficient way. Now, what does that mean? So, going back to the previous example, if we're going to store COM2026, each of the characters we will need 2 bytes. 2 bytes. And so COM2026, there's altogether 8 characters, and we would need 16 bytes to store all those things. But if we're going to store only one number, in particular, an integer, we can save up much more space. So for instance, if we convert this number into a binary format using short divisions, okay, which means we can divide this number by 2, by 2, by 2, by 2, and again, we have this representation. Now, what does this representation actually means? The last digit will means the 2 to the power 0, which is 1. This one will be 2 to the power 1, 2 to the power 2, 2 to the power 4. And so how do we convert this one back to 2026? Basically, what we're doing is to take out all the numbers 1 and add the corresponding number back, and we can form this 2026. So in this example, we get this digit will be 2 to the power 1, this one will be 2 to the power 3, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9, and 2 to the power 10. Now with all those numbers, I just say, we just add them up, that will equal to 2026. This number will require us 2 bytes to store it. Okay? Now, although these, apparently we need 1 byte and 3 more bits, that will be enough to store 2026. But remember, a byte is the minimum units we are discussing, so we're using 2 bytes in this example. If we want to store a much larger numbers, we will, for example, 100 millions, now we will need a little bit more bytes to store it. This is a tiny example you may think about. Try to represent this one into a binary format. In Java, okay, it's a programming language. When we're going to store data, we're going to declare our data into a primitive type, okay? And for different primitive types, for instance, sometimes it's going to use to store number, sometimes it's used to store characters or strings, sometimes will be used for storing the logic true or false. We use those types to store our variables, and we use those variables for in our program for some calculations or decision making. And next, we're going to introduce what Java has for the basic type. Numbers in Java. In Java, we will separate integer and decimal numbers separately. For integer, for some small integer, we could use byte to handle it, and shorts, int, or long, different types of integers that will require different number of bits. The larger we are talking about, the more bits we will require to use. For decimal numbers, we will use float and double. Now, for bytes, which has only 8 bits. Apparently, the all the possible values we can have for bytes will be from all going to 0 up to all of them going to be 1. So altogether, we have 256 different combinations. For half of them, we put it as the negative number. For half of them, we put it as the positive number, including the 0. So the range of byte will be -1 to 8 to 1 to 7. Now, if you want to store a number that is outside of this range, we will need another type. For instance, short. Short will use 16 bits, which range from 32,000 up to 32,000 positive. The next level and the most common type we're using is called int. That will require us to use 32 bits. Long will double of int. By means of double, it's not talking about the range is double, but the number of bits we are doubling. So the total numbers of possible value will be like this, ranged from -2 to the power 63 to 2 to the power 63 minus 1. To store decimal numbers, we're going to use float and double. The range of float and double is given here. Double, it gives you a much bigger number, okay? At the same time, it will also give you a more precise number. When we store a character, we will use type char. Now, a char can only store one character. This is very important. Each char is a 16-bit long, which consumes 2 bytes, encoded by unicodes. Each char must be either enclosed by a single code symbol, or it is represented by a number smaller than 65535. Okay, so what are the example of characters we can have? For instance, if you want to store character A, we can just say single code A or single code capital A. These two characters are different. We can also save some special symbols like the $, or let's say if you want to store Kevin, okay, you have to separate Kevin into 5 different characters and store them into 5 different variables. We can also represent some Asian characters. For example, the character Zhang. Okay, this character has the Unicode 6D78. Now, if you want to use Unicode to represent a particular symbols, you need to add /u in front of the Unicode. Okay. Now, in principle, all single code will contain exactly 1 character. In this example, single code surrounded by /u 6D78. This is 1 character, which is this one. Okay. Now, some of the program does not really want you to type Asian character inside the program directly. This is the reason, because different processor will save your file differently and may corrupt any Asian characters when you save text files. To avoid any problem when you are handling those Asian characters or other special characters, it is recommended to use Unicode to represent what you want if it's not a standard character. And this /U0060 will represent the character dash. Okay. Now we can also represent a character by a digit. For instance, if you use 100 to assign it as a character. Now remember this one without single quote, it is a number, 100. When we say a character is 100, it actually means the character has the Unicode value 100. 100 is a decimal number. When we translate to a hexadecimal number, it means 64. The character D has the Unicode 64, which represent the values 100. The next one is Boolean. Boolean represents the logic true or false. In computer, we only need one bit to store the value true or false. However, when you store Boolean values, you will still use at least 1 byte of content, as the minimum tokens we're talking about is 1 byte. It is more convenient to store that as Boolean rather than a character or an integer. Although a character T or F could represent true or false, the integer 0 or 1 could represent true or false in your program logic, but later you will see if you're going to use Boolean, it will be much more convenient. Boolean is very, very often to be used in condition, like if else, or it will be used in the loop. Now, one example you can see here, we say Boolean enrolled equals to true, which means this variable enrolled has the value true. Val equals to mark less than 35. Now, if that really depends on the values of mark. If mark is more than 35, then val will has the value false. But if mark is indeed less than 35, then the value of val will be true. The next example we'll see as a Boolean, we'll say while val, while this condition is true, we will do the following. We will retake until val is false. Now, so this example will give us some ideas of how Booleans work. For variables, declarations, and loops and condition, we haven't really talked about it yet. We will do it later. The next one we want to talk about is string. Remember, if we have only one character, we say this is a char. A string is multiple characters. When we say multiple, it means it could be 0, 1, 2, 3, up to, very, very long strings of characters. A string is a little bit different than the other types. For the other types that we have seen, let's say Boolean, short, byte, double, float, char, all these will start with a lowercase. A string is a little bit different. It will start with an uppercase. String is used to represent any length of characters. It always be enclosed by a pair of double quotes. String is also encoded by Unicode. For instance, we say Kevin, this is a string, okay? Hello, space, wow, exclamation mark. This is a string. This one, it is also a string, okay? In each of the string, it has multiple characters. Now, while we are defining strings or when we're defining our characters, sometimes we want to, uh, um, we could, of course, use Unicode to represent our characters. And for instance, if you want to uh, denote the double code, okay, and in a string, we can't just simply put a double quote inside because the program wouldn't know whether it is a termination symbols of this double quote or you really want to uh, display a double quote inside a string. So that's why we have something called an escape character. An escape character is backslash. Yeah? Okay? If you want to display a double quote inside your string, you will add an escape character in front of your double quote. So for instance, you want to say, I know Java, okay? So this double quote will have a backslash in front of it. This entire word will be a string. It will not be terminated in the middle because when the computer read it, this double quote, it is followed by an escape character. So the string, the computer will know, or we say the compiler will know, this symbol is indeed a symbol inside the string. If you want to display a slash, backslash, we could simply type slash, backslash twice, which will mean this is a backslash. To display single quote, okay, we could put a single quote directly inside a string or add a backslash in front of it. So both of them will be legitimate. Now you may wonder, why would I need to have a backslash to host this single quote? Now, if you want the single quote appears inside a character, in that case, you will need this backslash. A new line symbol. So for instance, if you want uh, the string to have an enter, okay, separate the two lines, we could use /n to represent a new line. So this one will give you so and the new line here. /t is a tab symbol. It will fill up the space until you reach a tab stop. Usually it will be 4 characters, which means if you have an A and then followed by a tab, it will fill up 3 more space, 1, 2, 3, and then followed by the things afterwards. Now, to declare a variables, where variables is extremely important. Without variables, we can't do any computation at all. We can't do any loops. We can't make any decisions. In Java, variable has to be declared before we can use it. Unlike Python, you can use a variable immediately, but in processor or in Java or in other many programs like C, C++, variables needs to be declared before it is used. This type of programming language is called strong type programming language. So To declare a variable, we need to tell the computer what types of the variables is it. Types could be int, float, double, char, string, which we have just talked about that earlier. These are some examples when we declare variables. For instance, int number of apples, followed by a semicolon. Now remember, every statement has to terminate by a semicolon. Okay, int number of apples, double, temperature, short, a little counter, chop, gray. These are variables, and each of these variables has its type. For example, number of apples will be integer, temperature will be a double, okay? Because temperature could be a decimal number, so we want that to be a double. A little counter, so it is a rather small counter. We use a short. Gray, it has A, B, C, D, F, so we just need one character. In this case, we use char to store it. Now, if you have more than one variables of the same type, you can declare them into one line. So for instance, int ij, I comma j, it means I'm going to declare two variables, I and j. Both of them has the type of integer. We can declare double A, B, C, D, E, and all of them will be doubles. We have 5 variables here, all of them will be doubles. This one, int A and comma double B, it will be invalid. Why? Because comma is only be used when you want to separate multiple variables. But B is not the same type as A, it should be in the next statement. So that's why this comma here should be replaced by a semicolon instead. After we have declared our variables, we can also assign an initial values to those variables. We want to give a value into these variables. So for instance, int val1, int value 1, we can put an equal sign after this variable, and then the number we want to assign to this variable. So after this line, the variable val1 will take the value 2026. Similarly, val2 will get 2007. And we say sum equals to val1 plus val2. This one, sum, will take the values 4035. 33. Sorry, my math. And this line, you can see val3 is ordinary variable declaration with our initial values. We can assign these initial values in the next line, like this one, and we can assign this with another values later. Variable namings. Now, we have 2 rules for variable namings. The first one is the hard rule. This hard rule you have to follow, okay? If you don't follow it, the program simply can't compile. The other one is soft rule, or we call convention. Convention could be violated, but violating a convention will lead to some misunderstanding and is a bad habit. Let's talk about the hard rule first. The naming of a variable must contain only letters and digits and the underscore characters. A variable couldn't begin with digits. A variable could not be using reserved words. And variables are case sensitive. So apples here is not the same as this one. So what is the sum of the valid variables names? For instance, small tree, big house, com2026, underscore, um, well, this underscore 2026 is a little tricky. We will talk about that. And do invalid uh, invalid variable names that will include 2026 because this one simply means this is because it starts with digits, so we can't use this one. Com hyphen 2026. This is also invalid because it contains a special symbol which is not an underscore. And Kevin Wang is not a valid name because there is a space in between. Do here is a reserved word which cannot be used as a variable name. Now, these are some reserved words in Java. We have made some of these words in italic. Those italics words we will not teach them in this course. And some of the words here will be some of the words here, instruct, go to, and const. They are reserved word in Java, but they don't have any function. All these words couldn't be used as a variable name. Now, for the convention, the variable naming principles. Variables should always start with a lowercase. This is in Java and C, where Java inherited from C a lot of things. So as this convention, a variable should always start with a lowercase, except it is a constant, which means the variables that we're not going to change it for the rest of the program. In that case, we put every letters in this constant in uppercase. A class name should always start with uppercase. Okay, so when we say class called snake, S-N-A-K-E, then we will have the S be capital and the rest will be lowercase. Okay, now you may wonder what is class now. Class, we will talk about that after half of the semesters. We're going to class. Right now, at this moment, we only need to remember variables should always start with lowercase, except for constants, where we use uppercase separated by underscore for between different words. There are two major terms in variable naming. One is called the camel case, one is called the snake case. Well, for our variables that has few words is combined with a few words here. For example, number of rounds. We put the first letter as lowercase, and the second and the third characters. Okay, the first word of the next word will be uppercase. So low, up, and up. For snake, we put every word as lowercase, and in between each of those words, we're separated by underscore. These two terms are equally important and equally popular in this in the programming community. You can choose any one of those. In this course, we are going to stick with this camel in our lecture notes. But in your program, you feel free to use either one of them. Now, when we say either one of them, please don't mix it. Okay, otherwise people will hate you. Now, some common mistakes when you're declaring variables. For example, in here, new variable is equal to 5. This is not acceptable because new variable has not been declared. So you can't use it. And this one is also giving you some error. Because when you declare sum as an integer, you can't put a decimal numbers into this integer. This won't be good. Also, when you want to use this variable, you must first give it initial values. Now, in this example, int val, this is correct. But the next one, there is a problem. Int sum equals to val plus 2. Well, the computer has no ideas about what is the values of val, so it could not simply perform this line of operation. So, in summary, we have talked about data types, types of characters, different types of numbers, characters, and logics using int, float, double, short, byte, character, boolean, strings, and the variable names and rules and conventions, and how we're going to declare variables. I'll see you in next chapter. Goodbye.